Hi everyone, this is Dr. Nali. So in this video, I just want to talk a little bit about how to name acids. Right now, we're just going to learn how to recognize and name them. Later on, we'll talk about the reactions where acids are involved. This page right here is taken straight from the Chem 10 lab on nomenclature. And the way you recognize acids is that they are compounds that release hydrogen cations, so they must have hydrogens in them, when dissolved in water. Now, what kind of compounds are they? So they're actually covalent compounds, but when they are placed in water, they actually release these hydrogen ions. So it's kind of a unique combination because usually only ionic compounds will release ions, but in this case, the covalent compounds that will release ions when they're mixed in water. It's important to make sure that the acid is dissolved in water, and to do that, we give it the symbol AQ, which just means aqueous, and all that refers to is just that that compound is dissolved in water. So for example, HCl could be a gas, in which case that will not be an acid. However, if you take HCl and you mix it with liquid water to make HCl aqueous, then the aqueous form is the acid, and then the gas form is not an acid. Okay, so this is clarify what we consider as acid and what is not an acid. So how do we name them? Well, it depends on what kind of acid you have. So there's two different types of acid. The first one we're going to look at is something called binary acid. They're acids that contain just your nonmetal anions, things like F-, Br-, and so on. So the way I typically recognize these acids is that they don't contain oxygen. So examples of these guys are HCl. Again, they have to end with aqueous. They start with an H, all of these acids. So HBr, for example, HI, HCN, for example, is a considered binary acid. H2S, that would have been considered binary acid as well. The way you name them is simple. First part of the name is the word hydro. And then the second part, you would look at the anion that makes up that acid. In this case, Cl, for example, is chlorine. So instead of calling it chlorine, you would change the name and end it in IC instead. And then afterwards, you end the name with acid. So HCl would be called, again, this has to be aqueous, would be called hydrochloric acid. So if you have, say, HBr here, again, same thing, you would start with hydro, and then Br is bromine, but in this case, you would call it bromic, and then you end the name with acid, okay? So here's another example, something a little different, H3P, but you don't change the way you name it, it's still hydro. P is phosphorus, so it becomes phosphoric, and then acid. Okay, so these are all the ones without oxygen in them. Now let's talk about the acids that have oxygens in them. They're usually called oxyacids. Another way to recognize them is these acids usually contain some type of polyatomic ions in them. So examples would be HNO2, HNO3. Again, I would put aqueous behind these just to make sure they're acids. H2SO4, etc. So you can see that all of them have oxygens in them. So the way you name them is different than the binary acids. With these guys, no hydro at the beginning. So remember, we start with hydro with all those binary acids. This one has no hydro. You just start with the name of the element in the polyatomic ion. So in this case, N, right, nitrogen. And then you would change the name here, ending either with OUS or with IC. Okay, so let me give you a quick example here. So let's say you have HNO2 and HNO3. Okay, the way you name them is as follows. So you would say nitrogen, right, is the N, but instead of calling nitrogen, we would call it nitrous for one, and then for NO3, we'll call it nitric. And then the ending of the name is the same, it's acid. So either nitrous acid or nitric acid. Now, so the polyatomic ion NO2, of course, is nitrite. Change that ite to OUS, and then nitrate is NO3, so you change that to IC, okay? Let's do it with another one. So just to kind of rephrase this a little bit before I continue. If you have your polyatomic ion ending in ITE, then your acid name would end in OUS. If it's ATE, then it would be IC. Okay, so let's try this out again. So let's say now we have H2SO4 aqueous and H2SO3 aqueous. Okay, so again, the name of the polyatomic ion itself, SO4, of course, is sulfate, and SO3 is sulfite. So now we can name this acid. We would call the top one, because it ends in ATE, would have to end in IC, so we would call it sulfuric acid, sulfur being the element. And then for H2SO3, it's ITE, so we would call it sulfurous acid. Okay, so hopefully you kind of see the pattern now in terms of how to recognize these acids. This one right here is the oxalate ion, so H2C2O4. The polyatomic ion name is oxalate, so then since it's 8, it's going to be IC, so I'm going to call it oxalic acid. Okay, so I hope this clears up any issues with naming acids.